Hi, I'm Stu from HiveMind Automation and welcome to the Hive. In this DIY project video, we're going to be taking a look at turning this pile of electronic parts into this HA switch plate. There's a bit to get through, so while I roll the intro, take a moment to subscribe and hit the bell icon to get notified when I release new videos each week, and let's get started. So in a previous video, we took a look at the HA switchplate or HASPOne MQTT wall controller for Home Assistant. In this video, I'm going to show you the steps that I took to build the unit. As always, there is a link to the GitHub project in the video description down below, and if you want to follow along, you do need to have that data. Now, a word of warning before we start building this unit. This particular project does deal with mains voltage, and you need to take adequate safety precautions if you're using the mains voltage version. There is a low voltage version available if you're not comfortable messing with mains voltage, and in fact, in hindsight, I'd probably recommend building the low voltage version of this project anyway, and I'll definitely be building one of those in the future. Because here in Australia, we can't really wire stuff directly to mains without some insurance problems. With all of that out of the way, let's take a look at our bill of materials. And for the record, there's no sponsorships here. I've paid for all of these items with my own money. Now at the center here and tying everything together is a custom PCB. The Gerber files for this PCB are in the GitHub repository. Now I ordered my PCBs from JLC PCB and I got 20 for around about, I think I paid less than $15, and that included shipping. To supply power to the unit, we have this Meanwell branded IRM0305 switch mode power supply to take mains voltage in the range of 100 to 240 volts in, and to output 5 volts DC with a rating of 0.6 amps. Now, if you are going to go the route of DC only without the mains voltage, this PCB has been designed to also accept the Meanwell SLC03 series DC to DC power supplies, and there's 3 models listed on the documentation. I've got some on order so that I can do more experiments. So if you're interested, comment below and I'll do a follow-up video with the DC only version. Again, I think the DC only version is probably the right way to go here in Australia. We've got a very simple 2N3904 NPN transistor here, a 1 kilo ohm resistor, and we've got a Wemos D1 Mini. Now, if you're not familiar with the D1 Mini, this is an ESP8266 development board, and you can see the ESP8266 here. It's very similar, in fact, to the Node MCU boards that we've taken a look at in previous videos. You'll note obviously that the D1 Mini is quite a lot smaller and has less I/O pins than the Node MCU, but it is perfect for our use case here and they are relatively inexpensive. We've also got various headers and connectors. So we've got headers to connect the D1 Mini to the board. We've got this header here, which I'm going to put into these pins here, and that's for diagnostics purposes. And we've also got this header here, which helps us to connect the display. And speaking of the display, we have the Nextion NX3224T024_011 is the model number. It's a 2.4 inch LCD touch display. Now, before we get into it, I'm going to actually turn this on to show you what the panel looks like. It comes with this cable that I've attached in the back here, and it also comes with this odd little connector to plug into micro USB and get power to it. So I'm just going to put the connectors on here, micro USB cable here, and plug that in that way. And that's going to power up, and it's upside down, of course. So we'll turn that around the right way. And you can see that that's powering up. It tells us some details about it: basic T series, the size, the orientation, the user SRAM, the SPI flash, and the MCU speed. And then it launches into a demo sketch that it's got running. So we can tap on any of these things and it brings up another page, tells us a little bit about it, and we've got this back button here. So the demo is pretty basic, but it should give you some idea of what we could potentially achieve with one of these. Now we're also going to need a micro SD card, and we're going to use that to upload a new firmware to this display, a new sketch if you like. We'll also need the micro USB cable that I've used here to program the D1 Mini. And also over on the 3D printer right now, I'm printing the desktop enclosure for everything to go inside. And all the STL files for the enclosure types are also available in the GitHub repository. Now, according to the wiki pages for this project, the first thing that we need to do is to deploy the Arduino sketch to the D1 Mini. So we'll do that now. The good news here is that there's a binary file that we can flash to the D1 Mini, much like when we flash our TAS motor onto various Tuya devices. So we'll head over to my laptop and I'm going to open up Tasmatizer. So tasmatizer.py. And we'll launch that, and I'm going to plug in my micro USB into my D1 Mini here, and back on my laptop we'll refresh the ports, and it's found TTY USB serial 14430, and we're using a self-resetting device, and we want to select the image we want to be on this binary file. We don't want to use a release or a development version. We want to use this binary file option here, and I'm going to click open, and I'm already in the folder inside here. So inside Arduino sketch we've got this HASwitchplate.ino.d1, so I'm going to select that binary file and hit open and Tasmatize. Okay, great. So the Arduino sketch is now on the D1 Mini, so I can unplug it. Next, we're going to need to upload the firmware for the Nextion display. Again, the firmware that we need is in the GitHub repository. Inside this Nextion HMI folder here, we've got this HASwitchplate.tft file. Now we need to copy this file onto a clean FAT32 formatted micro SD card. So I will pop my micro SD card into my computer, and you'll see it's just come up. It's called Untitled. If I open that up, you'll see I've already got the HASwitchplate.tft file there. So I'm just going to eject the micro SD card, and we're going to head back over to the display here, and I'm just going to pop the micro SD card into the back of the display, and that is a spring-loaded SD card slot, which is quite nice. And so all we need to do now, and what I'll do differently, is I'm going to take the red and black, so the +5 volt and the ground, and I'm going to attach those to the D1 Mini because we can, rather than using this little USB breakout connector. Okay, so we've got our SD card in, we've got the display connected to the D1 Mini, and I'm going to power it on, and you'll see board 1152 SD card update. The system detects multiple TFT files, cannot be upgraded. Please remove the extra TFT file. Okay, so apparently there's an extra file on there, so I need to disconnect that, and I'll put this back in the computer and see what's going on. It is worth mentioning there are some reports of there being issues with an SD card that's been formatted using Linux. I'm not sure about Mac OS, so we could be facing an issue there. I'm just going to copy this file and paste it into here, and I'm going to unplug the SD card, plug it back into our display, and we will power on the display, and hopefully this time it works. Okay, system detects multiple TFT files, cannot be upgraded, please remove the extra TFT file. That's interesting. Okay, so what I'm going to do is I'm going to head over to my PC and reformat this and try again. So I'll pause the video there. I'm going to go over to the PC, copy over the TFT file to this, and see how we go. Okay, and we are back, and I've just copied the only the one TFT file, the HASWitchplate.tft file, onto the SD card. Now, I believe what was going on there is because I'm using a Mac and I was copying stuff over, there are some hidden files that Mac OS puts into the folder structure as well. So I think that's what's happened here. So I'm going to insert the SD card into the back of the Nextion device and plug in power and see what happens this time. So SD card update after 0 seconds, copying SD. So that's updating now, that's awesome. So we'll let that run through, then we should be able to start on some testing. Okay, great. So now that that's done, it says check data 100%, update succeeded. So we are going to unplug the power, and on the back we can now eject the SD card. So now we can move on to testing. Now I'm going to wire up the D1 Mini directly to the display with, as we mentioned before, red on the 5-volt pin, black on the ground pin. We're going to also put the blue connector onto the D7 pin on here, which is this third one up. So D7, and we're going to take yellow, and we're plugging yellow into D4. So D4 is right next to the ground pin, so we'll plug that in there. Okay, and now we will plug the Wemos D1 Mini into the USB power, and we should power up. HASP initializing. Now, it's probably worth noting while we're waiting for this to boot up that you could quite reasonably run the HA Switchplate just like this, just the D1 Mini and the display here, and just DC power straight into the Wemos D1 Mini, and that'd be perfectly fine. It wouldn't be pretty, but there's certainly nothing wrong with that. If that's what you wanted to do, you could quite reasonably put this into an enclosure and run that like that without too many hassles at all. Speaking of enclosures, my 3D print is done, so we have an enclosure to put the unit in, and that is more or less what it's going to look like when it is done. So I'm looking forward to playing around with that. There's quite a bit of stringing inside the print. I obviously need to tune my print settings. The filament I'm using is a little bit old, so it might be to do with the older PLA filament that I'm using there. I wasn't expecting HASP to take this long to initialize. I might just give the D1 Mini a restart. I might disconnect and reconnect. So this seems to be the default. Okay, perfect. So I just disconnected and reconnected, and you see now we have our setup screen. So what we can in fact do now is connect to this Wi-Fi access point and do some stuff, and you could use the QR code to connect to it. I'm just going to go into my Wi-Fi over here, click on other networks, and I'm going to connect to HA Switchplate. The password is HASPlate, and we won't remember the network. I'll join that network, and we should then get a pop-up asking us to configure things, and we do. So we can configure Wi-Fi. We can also take a look at info, things like our uptime, etc. We've also got some updates in here, etc. I'll back out here. I'm just going to go to configure Wi-Fi. We're going to connect it to the Force, and I'll type in the password here. HASP node, I'm going to call this HASP node plate 01. The group name we'll leave as plates. Our MQTT broker is required, so we'll put 192.168.1.20, which is the MQTT broker for my Home Assistant setup here. We can leave the user and password. We won't worry about TLS. Admin access, we've got an admin user which is required, and a password is optional. I'm going to hit save. It's saving the credentials. It's going to try to connect the ESP to the Wi-Fi, and it says Wi-Fi connected. It's given us the Wi-Fi that it's connected to, which is the Force, and we've also got the IP address that it is on as well. So we might even be able to connect to that Wi-Fi IP address. So 192.168.1.149, and it's also got our MQTT broker that it's connected to as well. So if we connect to the IP address, we get the settings there for plate 1. It's also telling us that there is an update available, so we can update HASP to version 1.02. So let's do that now while we're at it. And we've got our update on screen here, and it's running through that now. So the update's just completed, it's restarting, it's initializing. Now I have noticed that this initializing step can sometimes take a while, so it's connected. We've got the Force and we've got MQTT connected, so we are good to go. So now that our first time setup is done, we're going to need to put all of these components together. So to do that, I'm just going to pop out to the workshop and I'm going to heat up the soldering line. There is a 3D printable assembly jig that I'm printing at the moment, and I'm going to try and see if that helps out with the soldering when I build another one of these. But for now, I'm just going to head out and solder everything together. Now, before I do that, I do like to do a dry fit. So the Meanwell power supply goes in here. We've got our transistor goes in down here, and we need to sometimes bend these legs out a little bit so that we can get the pins into the right holes. So our transistor goes into there like so. Our resistor, we need to bend these legs down again, and we can feed the resistor into these two holes just next to the transistor. Okay, like so. And our WeMOS D1 Mini is going up here, and this header is going here. And I'll put the D1 Mini headers in there, and this connector goes like so. There. So that's what it's going to look like when it's done, and we'll also plug the D1 Mini in, and the screen will also be connected here. Now there is a recommendation with this that we disconnect this header here and solder these wires directly to these connectors here, and then what we actually do is we use this connector inside this white connector here. This is a JST XH connector, I believe is the term for that, the part number, and it's a 4-pin, and I have a selection of these here, and it's this 4-pin unit here. So I'm going to pop out to the workshop, solder everything together. I will speed this section up because it's going to take a little while, but then when we come back we should be able to plug everything in and see where we're at. Okay, so we're back from the workshop and everything's soldered up. We've got our power supply there, we've got our headers for our Wemos D1 Mini, we've got our debug headers, we've got the header for the display, the transistor and the resistor in there, and we've also added a cable to plug into mains power, and that's just plugged into an extension cord over here. On the back of the display, I will mention that this was very tricky to remove this header, and I was not as careful as I should have been, and I actually tore some solder pads off the board and had to scrape some of the traces away to then solder direct onto the copper traces. So if you are going to do this method, be very, very careful. In hindsight, I think I would have instead just added another one of these plugs to this header so that we could connect the two ends of the cable that way. The recommendation is to remove that so that there's a bit more room inside the enclosure. So we've got everything set up now, and hopefully everything is going to turn on okay. So we've got our Node MCU in there. Now if we turn this on, we should get initializing, connecting to the force, and it is connected. And so if we, on our computer, go back to our IP address of the unit, which was 149, as you can see there, we've got the details here. So now all that's left to do is to put it into the enclosure, and we'll do that off camera. There's a few adjustments I need to make in order to get it to fit nicely into the enclosure. But once I've done that, we'll take a look at the finished product. Now, I did cover off the configuration of the HA switchplate in the other video about HA switchplate, so I won't bore you with those details again. Something I will recommend though is that when you are soldering the transistor on this unit onto the PCB, you do need to be very, very careful because that transistor is used as a switch between ground for the display here. So in the case that you have a firmware update failure, you can reset the display so that it starts again, and that I've had a couple of failures there where I may not have been as careful with the soldering of the transistor, and so it's not working properly. What you can in fact do in that case is you can just remove the transistor completely and just put a glob of solder across the 3 contacts for the transistor, and I'll be testing that out at some point as well. The only thing then is if there is a failure with the firmware update, you would and you have this installed in a wall, you would have to dig the unit out of the wall to then reset it. So there you have it, the HA switchplate or HASPOne assembly process. Now, I had a lot of fun building this project, and I'm looking forward to playing with the DC only version too, as at least here in Australia, that's going to be a lot more useful around my home. I do need to make some decisions about where I'm going to use my HA switchplate, so comment down below with your suggestions. I'm probably going to install one here in my set wall, so I've got a touch panel to adjust things as I need. That's all we have for this video, and I do hope that it helped you in your home automation journey. Be sure to comment down below with a home automation idea or DIY project you'd like to see me explore in a future video. Don't forget to follow HiveMind Automation on Twitter, Instagram, and Facebook, and those links are in the video description down below. If you like this video, hit the thumbs up button down below to give it a like, and if you're not already subscribed, please consider subscribing now. While you're there, you might as well hit the bell icon so you get notified when I release new videos each week. Lastly, if you like what I'm doing here and you want to help to support the channel, there is a Buy Me a Coffee link in the video description down below. Contributions through that Buy Me a Coffee link are put towards making more and better content for you to enjoy. Thank you so much for watching. I'm Stu from HiveMind Automation, and I'm looking forward to seeing you next time. Bye for now.